In number one, we're going to use the distributive law to multiply through this set of parentheses. So in other words, we're going to multiply square root of 5 times 4, and then square root of 5 times square root of 5. So square root of 5 times 4 is just 4 times square root of 5. And square root of 5 times square root of 5 is square root 25, or we can just write 5 without the square root symbol. And we just leave it like that. We can't combine these because they're not like terms. Like terms would have to have the same radical. All right, so just as a little example, we'll be seeing this later. If we had 4 square root 5 plus 3 square root 5, then we would just combine the coefficients in front to get 7 square root 5. Just like if we had 4x plus 3x, we add the coefficients to get 7x. All right, and number 2, again, we're going to use the distributive law. We're going to take 4 square root 3 and first multiply by 3, and then times 2 square root 3. All right, so first we have multiply the 3 times the 4, and we have 12, and just put the square root 3 next to it. 12 times square root 3 minus 4 times 2 is 8, and square root 3 times square root 3 is 3 without the square root symbol. So this is equal to 12 square root 3 minus 24. And we just leave it like that. We can't combine it further. All right, and number 3, again, distributive law. So first we have 4 times 3, that's 12 square root 2. Subtract 5 times 3 is 15. And square root 2 times square root 2 is square root 4, or just 2. 2 without the square root symbol. So we have 12 square root 2, subtract 30. In number 4, the instructions are simplify. Notice 20 is not a perfect square, but we could factor 20 into 4 times 5, and 4 is a perfect square. So this is equal to square root of 4 times square root of 5. And 4 is a perfect square. Square root of 4 is 2. So this is 2 square root 5, and that's simplified. That's considered square root of 20, a simplified form of square root 20. Okay, here we want to simplify as well. So we want to factor 640 into a perfect square times another factor. Well, 64 is a perfect square, and 640 factors into 64 times 10. So that'll work. So we have square root 64, square root 10, and 8 times 8 is 64. Square root 64 is 8. So the simplified form is 8 square root 10. In number 6, we have what are called like radicals, radicals that are the same. So in that case, we can just subtract the coefficients. So we subtract 7 minus 3, and we have 4 square root 5. This is just like the expression, the way we would combine the like term 7x minus 3x to get 4x. Again, we would just subtract those coefficients. In number 7, we want to combine two radicals, but they're not like radicals. Here we have square root 2, and here we have square root 50. So we're going to simplify square root 50 and hopefully obtain like radicals. Well, 50 is the product of a prime and a product of a perfect square and another number. So 50 is a product of 25 times 2, and 25 is a perfect square. So we are going to factor 50 into 25 times 2. So we break up radical 50 into radical 25 times radical 2, and we did that so that we can take the square root of 25, 25 is a perfect square, and replace it with 5. So we've simplified this radical expression by reducing what's underneath the radical symbol. So now we have this 5, we're going to multiply it with the 3 in front, so here we have 15. And now we do have like radicals, square root 2, square root 2. So we can just go ahead and add the numbers in front, add the coefficients, and we get 19 square root 2. Right, we want to do the same sort of thing here. We'd like to simplify these two square roots, so let's do that. So let's factor 27 into 9 times 3. 9 is a perfect square. And let's factor 12 into 4 times 3, and we chose that factorization because 4 is a perfect square. All right, let's take the square root here and the square root here. Multiply 5 times 3, we have 15 square root 3, minus 2 times 2, minus 4 square root 3. And now we have like radicals, so we're ready to subtract the coefficients, and we have 11 square root 3. All right, and 9, again, we want to simplify first, so let's factor 160 into square root of 16 times square root of 10, because 16 is a perfect square. And 490 can be factored into square root 490 can be factored into 49 times 10, so we'll write square root 49 times square root 10. And now let's take the square root. So here we have 4, and here we have 7. Multiply 5 times 4, and we have 20 square root of 10. Subtract 2 times 7 is 14, 14 square root of 10. Now we have like radicals, so we're ready to subtract these coefficients, 20 minus 14, and we have 6 square root 10. In number 10, again, we want to simplify and hopefully end up with like radicals so we can combine these. So let's factor 12 as 4 times 3, since 4 is a perfect square. And 75 as 25 times 3, because 25 is a perfect square. Okay, so take the square root of those perfect squares. Square root of 4 is 2. Square root of 25 is 5. And now let's multiply 7 times 2. So we have 14 square root 3. Subtract 5 square root 3. Like radicals, so we can subtract coefficients, 14 minus 5. And we have 9 square root 3.